I'm Michael Cade. I'm a senior technologist at Kasten by Veeam. And yeah, we're going to focus in on this. But what I want to do first, before we get into the demo, is the demo architecture. Now, this is not necessarily a real world use case. I don't necessarily imagine there's many customers out there that are rolling AWS EKS, Azure AKS, Google GKE, and K3S at the edge.
Love it.
But ultimately, again, it emphasizes that agnostic approach to being able to protect those workloads. Okay, so because I want to go over, first of all, we need to go over a little bit of the basics. How do we deploy K10? Now, K10 is part of it's a Helm chart deployment, but then what we've also done over the last 12 months is incorporate into things like Arcade, which is an application marketplace for Kubernetes. So being able to easily deploy that. Now, I'm using recorded demos. I don't normally, as most of you will know, I have got this cluster configured as well.
Some of the stuff you talked about there already, previous slides that you put up, you're showing something where you seem to be protecting applications which are outside of a cluster that you're deploying the software in. So what's the sort of strategy there? Are you intending to effectively go out and pull that data in, or is it part of a bigger sort of integration with the Veeam platform?
So without getting into the Veeam side as well, so Veeam Backup for AWS also has the ability to back up RDS as a standalone if you're using a virtual machine that is using a Postgres database in RDS. The premise for us from a K10 perspective is that if you've got your front-end application that lives in Kubernetes, and then that is leveraging a back-end database in RDS, then you want to be able to capture the whole application as one. We use a config map to join the two, and then we can get a consistent copy of all of that data in K10, either from a snapshot point of view, and then export that out to object storage. So as much as RDS is the first external data service, if you will, that we've written a blueprint for, you could write a blueprint for any external service, but K10 isn't going out to protect other external services unless it's linked to that
right.
Kubernetes.
So it's done purely for that scenario of consistency of application backup.
Exactly that, yeah. So I wouldn't imagine many people would use K10 to just back up RDS being used. We've got a point solution, modular solution that can do that with Veeam Backup for AWS. This is a really quick way of how do we get K10. K10's installed within the Kubernetes cluster. So each one that I showed you is very much going to have a K10 deployment in each one of them. And I know that was something that I think Chris mentioned before. So we'll definitely touch into that as well. But simply put is we're going to go and create a namespace where we're going to house our Kasten deployment, and then we're going to use Helm to deploy that. Now, like I mentioned, there's also an open source tool called Arcade, which we're very much in there, and it allows us to probably remove some of those Helm values if you don't need them, especially for a local development, a demo environment, just to get up and running. So Arcade gives you that functionality as well. So it's just another way of being able to deploy K10.
What are you using as your underlying storage component in that environment? Just native storage?
So this is actually to GKE. So I'm using GKE local storage, whether it's CSI, but also the native one. It's CSI as a default on this one because we integrate into CSI so that we can have a more efficient snapshot of the environment. So while that was running, that was just me speeding up the deployment, but it generally takes 2 minutes depending on the hardware underneath. Then if I go and jump into that, it's token authentication. Again, if we've got time at the end, Onka his team looks after the authentication and authorization piece within Kasten Engineering. So he's a good person to have up here and show that. But basically what we need to do is we need to go and get that token authentication, but we can use other authentication methods such as like Okta or anything to get into our environments. So I'm going to quickly get that, and then I'm going to log into the dashboard, and then you'll see that is just a single standalone dashboard. Like that is, if we've got our Kubernetes cluster in GKE, we've got our applications there, we can then go ahead and we can go and protect that. Where things get more challenging for the end user is if we're trying to manage multiple clusters and you've got multiple K10 dashboards to have to manage. So the K10 multi-cluster dashboard is there to consolidate those, but also give you the ability to manage them at the global level, be able to send out global profiles, i.e. object storage repositories or NFS or Veeam backup repositories, or also being able to send out global policies. You might have applications that live in all of these different clusters, but you've got the same SLA. So rather than going to each point solution, we want to go to one, the multi-cluster dashboard, and create a global policy for that. So the dashboard, very quick and easy to get up and running, or get K10 up and running. And then just a bit of background here. So this is, so from a multi-cluster point of view, I have already added, so my K3S is my primary cluster. So I've bootstrapped and set up the primary. And then I've added already the EKS and the GKA cluster. So what I'm going to show now is how quickly we can add in additional K10 clusters or K10 dashboards into our multi-cluster environment. I'm just the time as well. So as you can see here, like this is kind of what I was saying about, I've got a Kasten dashboard here, gke.vzilla.co.uk. So that's my Google one. I've then got another one that's my EKS, and I've got another one that's my K3D, and I've got, like, you can see how that could get, especially as we're seeing multiple clusters being deployed, but for multiple different applications. You might not just have one big massive cluster for everything, especially you're going to have one probably for staging and test and other areas. So within the dashboard, like I mentioned, we've got K3S, we've got GKE, and we've got EKS. So to simply add in, so and that still allows you to go to each individual one. So you can still go into that and then set, if your application is only in EKS, you can still drill down into that one from that one interface that we go to, and then we can create a local policy there. So you don't have to have multiple tabs and management panes open. And then we're going to go through and we're going to create our global location profiles, whether it be Amazon S3, Google Cloud Storage, Azure Blob, or NFS. And then we go in here and we've got the ability to use our kubeconfig to bring in that AKS cluster. You're going to actually see my kubeconfig has all of the other clusters as well, but I want to add in that AKS one. I'm going to simply have the display name and the ingress URL for the actual K10 dashboard. And if I take the ingress from the actual dashboard, the standalone dashboard, we can then add that in here.
So have you built a cluster just to run the multi-cluster dashboard?
No, so we're still protecting workloads. In fact, that's the last demo, Chris, is where the application is running on our K3. So right. Yeah, we're not using a whole Kubernetes cluster just
right.
for K3.
So is it running in one of them?
Yeah, so the way the architecture works for multi-cluster, if I'll just pause that, is so Kasten K10 takes its Kasten-IO namespace on each of the cluster.
Yeah.
And we set up a primary. Here you'll see that the K3S edge is the primary. That has another namespace within there called Kasten-IO MC, and that holds all the information to get to the other nodes within the cluster.
Right. So what happens if that cluster dies? Have you got Kasten-based replication cluster to cluster to move the multi-cluster namespace to another cluster?
So the policies are distributed to all of the local clusters. So the backup, the important part, will continue to work. And then we have the ability to bring up that cluster wherever that needs to be. I don't know if Tom actually, I don't know if you touch on that, but that's so the premise is that we want the policies to continue to run. So
would that not be a good service to run as a SaaS platform?
Potentially, I knew SaaS was going to come out. So SaaS is just as a broader topic, and I guess I can talk for the wider Veeam the whole company, is that, so it is strategic. We're looking at what that needs to be. I've been speaking to Enrico, I think, for 2 years about SaaS, right? Still looking into it. I think the key thing for us, and this is the same story that Enrico's heard every time, is we have over 40,000 BCSP, MSPs, managed service providers, that provide backup as a service, DR as a service for Veeam technologies. If we go and create our own SaaS, whether that's a management SaaS that just looks after visualization and policy management, or whether it's actually a SaaS-based product that enables us to have backup as a service, then we're losing that channel-centric model that we've had for the last 15 years, which is, I don't know if the number's been put out, but anyone can go and look at the latest PR that's been put out on Veeam's blog, and you can see the numbers that VCSPs bring in for us. Like working together in the channel, that's a hugely important piece of our revenue. So as much as from a product strategy point of view, we're absolutely looking into SaaS, it's a continuation of how we're looking into it.
Okay, we should talk about that separately rather than waste time now, but yeah.
So, and I guess that's the piece is that, and Tom will touch on this, is that from a K10 point of view, you can run K10 as a service provider and provide your own SaaS capabilities as an MSP. And we believe that the value is there at the moment, but also appreciate that a lot of other vendors in our space are doing other SaaS-based things.
I have a question about the target for the backups. So if you have this K3S, and you have a local repository, can you have a copy directly on another cluster or another target immediately? So for edge use cases, local copy, but actually a second remote copy just to disaster recovery purposes.
Yeah. So if we're talking K10 only, then yes, we'd do it with two policies, right? We'd send the data to two different places. If we're talking about being able to leverage a Veeam repository, then we can then leverage the backup copy function within Veeam to send it to multiple places. So,
no, but you can have multiple targets with a single policy, within a single policy.
Not within a single policy, you'd have to have multiple policies.
Multiple policies, okay.
Yeah. So I don't know, I'll probably need to go back a touch here just to show how simple it is to add that in with the kube config. This is why I shouldn't run recorded demos.
Or we shouldn't interrupt you.
Either, I'd never say that though, Chris. So you saw we're leveraging the kube config to then bring in that AKS cluster into this management plane so that we can then start protecting all of our workloads across all of those different locations, as well as having the point solution in each one as well. So if I had an application that spans over all of those locations, I can send a policy over all of those as a global policy and a global location and a global distribution, which is basically tying in all of the resources that you need to protect that. But this is where I've jumped ahead. So you see here that I have a backup policy, global Pacman backup, that mission critical application, all the high scores of my mission critical application. And you can see it looks exactly the same. If you have seen Kasten K10, it's very simple and intuitive to be able to jump in there, say what you want to protect, where do you want to protect it, and how do you want to protect it, and how frequent. You can dive into each one of them here, and there's a visual on what that looks like just above there. So now we're going to get into actually protecting that. And before I jump into that, let me jump back to, so I've just shown you that. No point in showing you that again. So another key part, so I've mentioned around like backup and recovery, or kind of at least in previous sessions, we've talked about backup and recovery within Kubernetes from a native standpoint point of view. But another massive use case that we've definitely seen over the last year is how do we move from one cluster to another? And obviously there's different parts of that configuration that look different. So whether it's storage, whether it's replicas, what use case is it? So being able to take something from a K3S as a workload where my production might live to something like AWS or GKE to be able to leverage some service there and then throw it away. But I want it to go, I want to spin it up. I want to change what the replicas look like. I want to change what the storage class looks like. I want to basically make that application look very different to what it does on premises or wherever that may be as to what it's serving the data to the end user. I want to leverage that data. I want to use that data for something good. Again, me and Enrico have spoken about like copy data management in that case as well, right? Being able to put that data to work somewhere else, as well as being able to migrate an application from one cloud to another and back again. kind of bringing that agnostic approach. We don't care whether it's underpinned by X storage or Y storage, because we can freely move that between. We still have to depend on the laws of physics to move that data from wherever it needs to be, but we've got the ability to do that being only software driven. Now I get to show you the mission critical application. So currently it's sitting in K3S. Now this is a Node.js front end and a Mongo database back end. Now I could just show you Mongo database and go in there and run some syntax in there and show you what that table looks like, but it'd be much more fun. It would be much more fun if I could play Pac-Man and get you all to do it as well. If you go to apps.vzilla.co.uk, you can have a little game. I've made sure there was one there for you, but we won't be using that data. So you see there that I've got a list of those mission critical data within my Mongo database. And you can see there that it's running in K3S. It's on a particular host within that cluster. Now, if I jump back and I go on to what cluster am I going to? AWS. If I go to my EKS cluster, so the one there, get kubectl, get namespaces, that's my K3S cluster. And now if I quickly jump over to my EKS cluster and we do a kubectl, get namespaces, surprise, there's no Pac-Man. We don't have anything running there at the moment. Also, I don't know if I do it in this demo, but if I go and look at the storage classes, the storage class on K3S is going to be different to what it is in EKS. And that's a common trait between all of the clouds. They all have different storage. Then we have this global policy that we have set called import Pac-Man. I want to restore it after import. So I want to run that on a schedule. And I want to do this transformation. I mentioned this in the roadmap slide. I want to change the storage class and I want to change the load balancer that we're using. Now, we could have that do so many more things. Anything in Kubernetes, anything in those YAML manifests that deploy our application, we can manipulate that as part of that transformation process. We then use an import key that is generated as we take the backup, and we use that in that config data import, and then we say, when do you want to do it? And we now have the ability to do that on demand or scheduled. So we can be constantly sending data between different clusters and even spinning it up and then putting something in place to remove that as well.
So this transformation process also applies to transitions between OpenShift and generic Kubernetes, right? Where some of the constructs might be different. Can you speak to that point?
Yeah, exactly that. So the ability to really change what that even looks like is there, because we've got everything in code that we're basically manipulating as part of that. So yeah, the great example, should have definitely used that, Adam, as a demo, because yeah, being able to go from one OpenShift cluster to a GKE or another type of cluster, that would be a pretty solid demo. Maybe giving me idea for the next one. Sorry, I'll just stop that. So we're going to go and run it again. Or we're going to run it. We haven't run it first time. And then what we're going to do is go back to the command line. So we could stay in the UI and it will tell you everything that's going on, but where's the fun in that? We need to see actually what is going on. So going in there and doing a kubectl get pods, you can now start to see, and I've sped this up, obviously it's not been 28 seconds, but you can start to see the restore pods are coming up to bring back the data. You can see the Pac-Man pod, you can see Mongo coming back, and now the restore pod is going away. And now if I go get service, I should have a public facing IP to go and see those high scores or go and see those in a different location. That K3S piece is still very much there. So production is still very much happening. And maybe this use case was just to see what it looked like over in a different cluster. Maybe we were migrating and we wanted to do the flip over and the switch. And we could do that by canceling or stopping what we had in K3S. So now, as you can see at the top, I'm on AWS. I'm in EU West 2C. And you can see all of those mission critical data points are in there that live in that Mongo database.
I don't think some of those high scores are real.
The hacker one. The hacker one gives it away, I think, where you can Yeah, I'm not going to give it away because I use that a lot in VMware user groups. So that's really a really fast way of looking at multi-cluster, very fast way. So again, just to reiterate, is that K10 is deployed in each one of those clusters and can look after local data protection as well as being clustered together. In this instance, K3S was my primary that looked after the whole multi-cluster piece, but all of the policies are distributed out into each of the nodes or each of the clusters within our environment. Clusters everywhere. I've got to have a meme, any CFD that I do. So key takeaways. So why so many clusters? I think you'll probably know this is probably benefit of the audience watching in on YouTube is there's multiple providers. They have multiple services. And we heard from multiple people today that are already talking about leveraging the cloud or hyperscalers for different services for different parts of their workload, different parts of their data, different data types. So being able to pick and choose to be able to do that from an organization structure point of view, it might be that an application owned by one team needs to be on or has been chosen for the IT team to be on one distribution of Kubernetes. So you and then you inherit that is another way. Then also geo constraints, depending on what that application is, we might need to pick and choose what that needs to look like. Scalability as well. They're not can't scale endlessly. So again, it might mean that we have multiple clusters to be able to deal with that. That's less and less that we're seeing, apart from potentially maybe out there in the edge where you might have a large scale Kubernetes cluster, but with much smaller resource out there running there. I don't know if Glenn or Enrico, I know you talk about the edge quite a bit, but that's definitely what we're seeing in that you have much more smaller compute modules out there at the edge. So you have much bigger clusters to have to handle and deal with.
There are also the fact that many organizations don't have the skills to manage large Kubernetes clusters. So they become more complex and, they lose control very quickly.
Yeah, and I think before getting into this, and this kind of hands over to Anka anyway, is that I think that's a huge part of everything that we talk about from a K10 point of view. K10 is there to be super simple, but can be as complex as you need it to be from an API perspective. K10 lives within the Kubernetes API. So everything we do, once it's deployed there, we can leverage that API. So I've showed you quite a bit of the UI, and I think I said this at the last Cloud Field Day as well. But everything that we've done can be done from a Kubernetes API as well. So that's another big part.
Why am I using K10 to move data around and not something like a native data service within my database or some other application level thing? Why are people using the backup system to move data around?
Well, there just isn't, right? If you're locked into a particular storage or cloud, they probably don't want you moving that. A database point of view, you still need to be able to move that data from A to B as well. I guess there's potentially native tools that could do that, but it's only going to be very much the database that allows you to do it, not the whole application. Right. Everything that we concentrate on is the application. Again, going back to what Chris mentioned, if you've got RDS and the front end is in Kubernetes taking full advantage of the scalability, then we're looking at the application. So being able to lift and shift that, but also parts of that as well. We can be granular about what we move as well. We don't have to take the whole application and recover that in a different location. We can be granular as well. So I think...
Okay. So there's not really any other way of doing this in Kubernetes in a satisfactory way. So you'll pretty much like, well, we can, so we will.
Yeah, and I think that's another real strong focus on the team is staying agnostic to that as well, not caring what that storage is or what that platform is underneath.
I think so. So wouldn't it also be true that like if I'm using one of the hyperscalers Kubernetes implementations, right? If I don't have a plan for migrating that to some other hyperscaler or on-prem, I'm essentially locking myself in and I'm giving up my sovereignty on that. I need to have a plan to get out at some point, just even if I don't need to, just to know that I can get out if, God forbid, the US East 1 goes down 3 times in a month. I mean, that never happened. So how do you spin up
That's the
that?
fourth time it's going down.
Is it down now?
4 times, isn't it?
Maybe it's 4 times, but the point is, like, you just never know. And since you brought up the edge, as 5G starts to become more mature, all of, the thing about 5G is it's all really implemented is what they call cloud native functions. They're containers, it's Kubernetes, but the different implementations that are going to come out on, depending on what carrier, you could have one carrier using OpenShift, one using K3, they could be using, you don't know what they could be using. So being able to, lift your application up across these different platforms, as that becomes a more mature discipline, it's going to be an imperative. It's not going to be a nice to have.
So, 100% agree, obviously. But I think also add on to that cloud piece is storage as well, right? Like being able to get out and about from different storage vendors is another key aspect of that app mobility, being able to move freely from whatever that needs to be.
I have an operational question. I mean, when you talk about migration, it's true that usually, these applications are not big in terms of data that you're managing, but actually they are getting bigger. So can you do a series of backups and restore to minimize the time during the migration on which you have, to stop everything? As
in seed a backup, like to a location. Yeah, absolutely. So I clicked there's an option, a checkbox that says restore on, import on restore on import, which will actually do the restore, which will bring everything up, like exactly what I did. But maybe we don't want to spin everything up, but I want everything there just in case. And we can be quite granular about what that looks like as well. So we can push everything over there. We can transform it, make it look however we need it to be.
Can you do additional incremental backups and restores? So just to get the last few hours to sync. Because if I need to do a full restore, then, and I have 100 terabytes of data, then it becomes a problem.
Yeah, you're waiting for that you're waiting for everything. So yeah, it is a seed of that, right? So.
Yeah, so one way we do incrementals is, for example, in big cloud providers, just using the underlying snapshot and then migrate mechanism through the cloud provider APIs. And so that's actually a common use case that kind of fills what you're asking about, I think, where you can do a lot of copies, and the more you do the migrations and copies, the more efficient it is because you're getting incrementals each time.